Hello everybody and welcome back to Higher Maths. Today we have the excitement of a new topic. Oh yes, the new topic is called Recurrence Relations. I will start with something that you might recognise from National 5 and last year, and then I'll explain what a recurrence relation actually is. So you can see there the question. You buy a car for £8,000, its value depreciates by 6% each year. How much will the car be worth after 4 years? Now, in National 5 Maths, you would have come across questions like this, where you would have done something called a repeated percentage. How we're going to do this time is almost like a step back. It's the longer way of doing it, but it ties in nicely to how we're going to look at recurrence relations as we go on, and they're a little bit harder than just this basic example. So, how will we start the question? Well, the value of the car is 100%. And it depreciates by 6% each year. So that means that the car is worth 94% of what it's worth at the start of each year. Okay, remember, we don't just find 6% and times it by 4. That's not what we're doing. We have to go down by 6% every single year. Which means that after 1 year, we can take the £8,000 and multiply it by the 94%. But the 94%, we need to change that to a decimal first. So 94%, remember, as a decimal, would be 0.94. So I'm going to do 8,000 multiplied by 0.94, and then we're going to get an answer for that. Now, you would have to use a calculator for this. And if I do that calculation on my calculator, I get £7,520. After 2 years. So now I'm going to take the new value, and again I'm going to multiply that by 0.94, because yet again it goes down by another 6% that year too. And that gives me, you can check this on your calculator, £7,068. 0.8 is what the calculator says, but I know it's money, so I'll make it 0.80. If I want to do 3 years, again, I take my last answer, £7,068 and 80 pence, and I times it by 0.94. Check it on your calculator, you know we'll have to do a little bit of rounding here because it gives me an answer that's 3 numbers after the point and I only want 2. So that's the value after 3 years, and then finally after 4 years we take that value there, £6,644.67, and we times it by 0.94, and it will give me my final answer. I made a mistake on my calculator, so let's go again. 6644.67 times 0.94 equals. Try it again, made a mistake. £6,245, and if I round it correctly, 99 pence. So that is the long way in terms of what you would have done last year. Okay? I'm sure if you remember correctly, your teacher would have told you the fast way of doing it, which would have been 0.94 to the power of 4 multiplied by £8,000. And that gets you straight to the answer. But for what we're going to do this year with recurrence relations, we need to go back to this longer way of doing it. I also have to introduce some notation, how we actually write this stuff down. I'll show you what the recurrence relation would look like for this question, and then explain it a little bit. The recurrence relation is this thing here. How we say this, un add 1 equals 0.94 times un. This is new notation for you, okay? The U is always going to be there. The N we can replace by a number if we want, okay? What I want you to notice is that each answer here relies on the previous answer. So we got £8,000 as our first number, and then we got our next answer of 7,520. We have to use that into the next year, and then we have to use that answer into the next year. You're always using your last answer to get your next answer. This £8,000, the cost of the car, that is what we call U0. It is the initial amount that we're given in the question. What I can also say here is that U0 is £8,000. After 1 year, we could call that U1. 2 years, I can call that U2. That's where the numbers are going to go. Okay, basically first year, second year, third year, fourth year, fifth year, or if it's months. Okay, what I want you to also notice is if you replace n with 0, over here you would get 0 add 1, you would get 1. So to get the next answer, U1, you've got to use the last answer, U0. To get U2, you would have to use U1. We're always using the last answer to get the next answer. That's an important thing for you to realise in this thing called recurrence relations. Okay, another example of what you might have done last year. Your granny puts £10,000 into a bank account for your 18th birthday. Lucky you, rich granny. The account earns 5% interest each year. How much money will be in the account on your 21st birthday? Okay, with same starting position, we're going to start with 100%. Now this time, you are going to earn this interest each year. The amount of money in your bank account will go up by 5% each year. So you're going to have 105% of last year's bank account next year. I want to change that to a decimal. If you can't remember how to change a percentage to a decimal, remember you just need to divide it by 100. Okay, 10,000 is the initial value, and that's on your 18th birthday. So on your 19th birthday, we would have 1.05 multiplied by 10,000. Remember, we take this thing here, which is actually called the multiplier, and we're going to multiply that by the initial amount of money that you've got to get your next answer. And that would be £10,500. For your 20th birthday, you take that 1.05 and you're now going to multiply it by your last answer. Always building on that knowledge. To get the next answer, you've got to use the last answer. And that comes to £11,025. And then on the 21st birthday, you take your 1.05 and again you multiply it by your last answer. And on your 21st birthday, you would have £11,576 and 25p, which would be the answer to the question. Now, in terms of recurrence relations, in terms of what we're doing at higher level, I'm going to write out what this recurrence relation would look like. For this example, UN add 1, so my next answer is 1.05 times UN, which is my last answer. I can say that U0, the initial amount, was £10,000. If I wanted to write my answers out in this fashion, my 19th birthday would be the next answer, which would be U1. The 20th birthday would be the next answer, which would be U2. And finally, 21st birthday would be U3. All the time trying to build the new knowledge of this thing called recurrence relations. But these examples are a bit easy. These examples are what we would have looked at last year. The recurrence relations you're going to work with are going to be a wee bit more complicated than that. Right, let's have a look at this first question here. A family has taken out a mortgage for £50,000 on a house. The interest charged on this sum is 6.5% per annum. They have agreed to pay back £4,500 each year. How much will the family owe after 3 years and 5 years? So what I'm going to do here is I'm going to try and set up a recurrence relation for how much money they owe. And remember, this is new, so as I do it, you're going to be learning things here, and you might spot a couple of things. You might need to have a wee think about what I'm doing. So, first things first. In this question, it tells me that I've taken out a mortgage and the interest is 6.5% per annum. Okay? So I'm starting at 100%. I'm adding on 6.5% because the interest, remember, gets added on. So that would take me up to 106.5%. I want to change that to a decimal by dividing by 100. It is 1.065. Okay? Now, it says that the mortgage was £50,000. So that is the initial sum of money. But with a mortgage, you obviously pay back money each month, each year. And they have agreed to pay back £4,500 each year. So this is taking the question and we're going to make it a bit harder compared to a National 5 question. I'm going to try and set up my recurrence relation. UN add 1 will equal 1.065 times UN. Right. They have agreed to pay back £4,500 each year. That's what the question says. So in terms of how much money they owe the bank each year, it will go down by £4,500. There is my recurrence relation. It's a bit harder than the first two examples because we have this takeaway bit here. Okay, but remember what the question says. A family has taken out a mortgage of £50,000 on a house. The interest charged is 6.5% per annum or per year. They have agreed to pay back £4,500 each year. How much will the family owe after 3 years? So, I've started at 100%. The interest is getting added on, 6.5%, so that takes me up to 106.5%. I change that to a decimal by dividing it by 100, it's 1.065. The notation that I use will always be this. UN add 1 will equal this thing here, 1.065 times UN, and because they're paying back £4,500 each year, I need to take off £4,500. I know that the value of the mortgage at the start was 50,000. So there is my recurrence relation. Now they want me to work this out. How much will I owe after 3 years and after 5 years? So let's have a wee go at doing that. U1, the first year. I need to take the 1.065. I need to multiply that by 50,000. And then I need to take away £4,500. Go to my calculator to work that out. 1.065 times 50,000, take away £4,500 will equal £48,750. So after 1 year, that's how much they will owe. For the second year, U2. Again, remember my recurrence relations, this thing here, so it's 1.065 times, we need to use the last answer, take away £4,500. So each time to get the new answer, you're going to have to use the last answer. type that into the calculator, and after 2 years they owe £47,418.75. U3. To get the next answer, again I'm using the same recurrence relation, so it's 1.065 times my last answer, always using the last answer to get the next answer. Take away the 4,500, and that's going to give me 46,097 pence. So I've answered part A, which was what will I owe after 3 years. Part B was what will I owe after 5 years. Well, I just need to keep this going. U4 is going to equal, my recurrence relation is 1.065 multiplied by my last answer, take away £4,500. That gives me £44,491 and 3 pence. Always, to get the next answer, use your last answer. And then finally, it wanted me to do U5. So that's going to be 1.065 multiplied by my last answer, take away £4,500. And that's going to give me, as the final answer for how much I owe the bank after 5 years, £42,882.95. And that is how we set up and work through our recurrence relation. The really important bit that we're looking for in each question is the percentage and this extra bit here. Okay, it might be a take away 4,500, but it can also be an add, and I'll show you one of them just in a little second. Right, question number 2. An industrial complex has requested permission to dump 40 units per week of chemical waste into a sea loch. It is estimated that the natural action of the sea will remove 20% of the waste per week. How many units of chemical waste will there be in the loch after 2 weeks and 4 weeks? So what I've said to you is we need to identify the percentage, and then we need to identify if there's an add bit or a takeaway bit as well. So it says in the question that the sea will remove 20% of the waste per week, but they have given permission for a company to dump 40 units in every week. So let's see what that recurrence relation would look like for us. So I'm starting at 100%. It says that the natural action of the sea removes 20%. So that's going to take me to 80%. And if I change that to a decimal, it's 0.8. So my recurrence relation will look like this. UN add on will equal 0.8 times UN, and then we need to look at this extra bit. So it says in the question that there's been permission to dump 40 units per week. So the amount of waste in the loch is going to go up by 40 units each week. So this time I am going to add on 40. In the last question it was take away 4,500. This extra bit here can be an add, it can be a takeaway, it just depends on the question. I also want to know what the initial amount of waste was. So in the question it says, oh, it doesn't say. So it doesn't mention how much waste there is at the start. The reason it doesn't mention it is because we are now assuming that there is no waste in the loch at the beginning. It doesn't tell me there was any waste, so I'm just going to assume that there is no waste in the loch. So that means that my U0 number is 0. Right, I need to work through this to get U1, U2, U3 and U4. So U1 is going to be 0.8 times my last answer, add 40, and that works out to be 40. U2 is going to be 0.8 times my last answer, add 40. And that works out to be 72. So after 2 weeks, there's 72 units of waste in the log. U3, I take my recurrence relation, which is 0.8, I times it by my last answer of 72, add 40. Always remembering that your next answer is based on your last answer. That's how we're doing this every single time. 97.6. And then to get U4, I take my 0.8, I multiply it by my last answer, and I add 40. $118.08. So each time here we're setting up a recurrence relation. To do this, you're checking the percentage that's mentioned. Is it an add percentage? Is it a takeaway percentage? Start at 100% and do that, and then change that to a decimal. That is always telling you the thing we're multiplying by. Then we need to go back into the question and read to see about this extra bit. It was an add 40 in this question. It was a takeaway 4,500 in that question. And we're also looking to see what U0 is. Okay? Time for you to try a question. You're going to try question number 3 there. A warehouse restocks by ordering 5% of the existing stock at the beginning of each month. During each month, 1,000 items are distributed from the warehouse. If the existing stock is 5,000 items, will the warehouse ever run out of stock? I want you to set up a recurrence relation. I want you to write down what U0 is, and then I want you to get U1, U2, U3, U4. Press pause, on you go. Okay. So it says, the warehouse restocks by ordering 5% of the existing stock at the beginning of each month. So I'm going to start at 100%. It is restocking, it is adding in more stock. So I should be adding on 5%, what comes to 105%, and that's going to change to 1.05 by dividing by 100. Okay, that means my recurrence relation will start with UN add 1 equals 1.05 UN. In the question, it says that during each month 1,000 items are distributed from the warehouse. So how much stock in the warehouse goes down by 1,000 each month? Take away 1,000. What about U0? If the existing stock is 5,000 items, U0 is 5,000. So there is my recurrence relation. I've set it up. I just want you to work through U1, U2, U3, U4. Let's see what's happening with this stock. So for U1, it's going to be 1.05 times the answer before it, which is 5,000. Take away 1,000. So into your calculator you go. After 1 month, we have 4,250 items of stock. Don't know why I did the pound sign. Right, U2. So you're going to take 1.05, you're going to multiply it by your last answer, and you're going to take off 1,000. That comes to 3,462.5. I know you might not think you can get 0.5 of a bit of stock, but this is a mathematical problem. We're going to get decimals involved in it. We'll just disregard them at the end, but we'll keep it there for the time being. U3. Recurrence relation is 1.05 times my last answer, which is 3,462.5. Take away 1,000. gives me an answer of 2,635.6. U4, I'm going to take 1.05, I'm going to multiply that by my last answer. I'm going to take away 1,000 and work out what that is. 1,767.4. And we're going to leave it there just now. I just want you to get the idea of how you get the next answer from your last answer. Okay? There is a fast way of doing this on your calculator if you've got a scientific calculator. Okay? If you want the fast way of doing this, you type in the initial value. So you would type 5,000 into your scientific calculator and hit equals. Then type times 1.05 minus 1,000 and hit equals. You should see this answer. Hit equals again on your calculator, you'll see that answer. Hit equals again, you'll hit that answer. Hit equals again, you'll see that answer. Then you can keep hitting equals and see if you ever get down to 0. It's a nice way of doing it on the scientific calculator. It just makes things go a little bit faster. Right, another one for you to try. Question 4. Sea lice are affecting the salmon on a fish farm. It is estimated that each year 40% of the population will die if no cure can be found. Each year the farm is restocked with 1,000 salmon. If the original salmon population was 400, find the remaining population after 2 years and 5 years. Okay. Again, you're going to have to look for a percentage. You're going to have to see if the percentage is increasing or decreasing. You're going to have to look for this add-on or take-away bit at the end. And then you're also going to have to establish U0. So try and write that recurrence relation for me now. Okay. So, each year 40% of the population will die. So I'm starting at 100% and I'm taking away 40%. That's going to leave me 60%, which is 0.6. So my recurrence relation should start UN add 1 equals 0.6 UN. Let's go back into the question. Each year the farm is restocked with 100 salmon. So each year they add in 100 salmon. So I've got my recurrence relation. What about U0? If the original salmon population was 400. There we go. So we've got a recurrence relation set up. We need to work out how many salmon we've got after 2 years and how many salmon we've got after 5 years. So U1 will equal 0.6 multiplied by my last answer, add on 100. Okay, remember, if you want to do this the fast method on your calculator, what you're going to have to do is you're going to have to type in 400 and hit equals times 0.6, add 100, hit equals. You should have 340. To get U2, I'm going to have to do 0.6 times my last answer, add on 100. Now, if you've done it the fast way, all you have to do is hit equals on your calculator and it will tell you immediately what the next answer is going to be, which is 304. To get U3, it's 0.6 times my last answer times 100. Remember, if you're doing it the fast way, all you have to do is hit equals. Use the calculator, let it work for you. 282.4. And then if I'm going to get U4, I'm using 0.6 times my last answer, add 100. Remember, to get the next answer, you are always using your last answer. I cannot stress that enough. That comes in at 269.44. And then finally, it also wanted me to get U5. So I take 0.6 and multiply that by my last answer. And I add on 100. Again, if you're using the fast method, all you have to do is hit equals on your calculator. And I'm going to get 261. This time I will round it to 1 decimal place, 0.7. And that is how we do recurrence relations. Okay, each time remember what we're looking for. In the question we're looking for the percentage. Is it an add or take away percentage? Once you get that, change it to a decimal. Set up your recurrence relation. Un add 1 equals this thing times un, and then you need to go back into the question and find out this little extra factor. Is it an add? Is it a takeaway? Then you need to identify what U0 is, again by reading the question. Right, thanks everybody. See you next time.